Good afternoon, class. We're going to continue for the rest of this module 2 practice test. For the following function, we want to find its inverse. The function is 2x minus 7, and we want to find f inverse of x. The process is very simple. Number one, we're going to change the name f of x to y because it makes it easier to deal with. The next step is to interchange x and y. So this becomes x, this becomes y. And right here, in this step, we do have the inverse. However, as you know, we always solve for y. So I'm going to move the 7. I get x plus 7. And I'm going to divide both sides by 2. To get to y. And that is the inverse. Now we give it the name f inverse of x. This is the notation. As you recall, it's read f inverse, not f to the power of -1. F inverse of x, x plus 7 over 2. Now, we want to show that we've come up with the correct answer, and in essence, we want to prove that. And the proof is that the composite function of f of x and f inverse in any order must give us x. Therefore, f or f inverse of x or f inverse of O f of x must be x. So let's stick with f or f inverse, which means if I want to go with f or f inverse, I'm going to replace the x with f inverse. F or f inverse. I'm going to replace the x with f inverse. I can drop the 2's and I get x plus 7 minus 7, which is x, and that is the proof. Now, this is good enough, but if we were to show f inverse or f, and you don't have to show both of them, then it would look like starting with f inverse. We are going to replace the x with f of x. Use a different color, which is 2x minus 7. As you can see, minus 7, positive 7, they cancel each other. Get 2x over 2, which is x. So that is also the proof. Do we have to do both? Absolutely not. One is good enough. I can't emphasize this enough, but I did both for practice. Let's move on. F of x is given as x over x plus 2. We want to find the inverse.
Sorry to interrupt, Professor. I had a question about how you proved the previous one.
Go ahead.
So on top of what's squared in the blue rectangle, does that say f of -1 times x, or is that saying f o f?
F inverse O f of x. It's the O, the composite function.
Okay.
F inverse O f of x. It looks like of, but F inverse O f. In other words, we can rewrite it as such. F inverse O f of x, okay? And in that case, we start with F inverse. We start with F inverse and replace the x with f of x. Becomes 2x minus 7 plus 7 over 2. We can cancel out the negative and positive 7. We get 2x over 2, which is x. Also, let me do this. This was f inverse of x.
Oh,
Does
okay.
that make sense? Okay.
Yes.
All right,
Thank you.
let's move on. My pleasure. All right, so again, if it helps, just put this either in brackets or parentheses. I'm going to put one of them in brackets, one of them in parentheses on purpose to see it makes no difference. We want to find the inverse. So the very first thing we do is to change f of x to y. Again, the reason is because it makes it easier to work with it. Now we interchange x and y. That means this will change to x, this will change to y, this will change to y. So y becomes x, x becomes y. And right here we do have the inverse. However, we continue to solve for y, which means we are going to do the cross product. Let me make this a fraction, x over 1. So we multiply these two, we multiply these two. This is the cross product. So this would be x times y plus 2, which means x times y plus 2x. And this will be y times 1 equals y. Okay. In other words, if I were to write this, I could have, okay, so x times y plus 2 equals 1 times y, and we get this line. We are solving for y, which means we are moving things such that all the y's are on the same side. So if we move this, becomes minus xy on the right side. And I can factor out the y on the right side. Becomes y times 1 minus x. Since I'm solving for y, I will divide both sides by the parentheses 1 minus x. And now I give it a name, f inverse. Instead of y, I'm going to call it f inverse. One thing I want you to know, the reason I put the second one, if we go this route, 2x equals 1 minus x. The way you move things around, if you move the y to the left, 2x to the right, you may find this one. What happens is that you should recognize they are identical. If you multiply the top by -1 and the bottom by -1, you get this one. So if you come up with something that looks slightly different, it is still the same answer. Now, let's look at the proof that their composite function equals x. So let's look at f of f inverse. And again, let me put brackets here so we know we are looking at the composite function of f and f inverse. So the f function is x over x plus 2. Replace both x's with what we found as f inverse. So the top changes to 2x over 1 minus x. The bottom has this one here plus 2. That's the meaning of f of f inverse. Now you are dealing with a complex fraction. How do you simplify a complex fraction? You multiply by LCD. The top and the bottom both have the same denominator, 1 minus x. So if I multiply the top and the bottom by 1 minus x, I can get rid of both fractions. So if you look at the top one, this cancels out this one, you get 2x. If you look at the bottom one, when you multiply these two, this cancels out this one, you get 2x, and then you multiply these two. I want to make sure that everybody understands what's going on. So you multiply this by this, and the result is that 1 minus x goes away. You multiply these two, 1 minus x goes away. You also multiply 2 by 1 minus x, and you write that. Now, when you distribute number 2 over these parentheses, you get 2 minus 2x. Everything else remains unchanged. And so I can cancel out the 2x with negative 2x, leaving me 2x over 2, which is x, and that's the proof. I recommend for practice, you look at F inverse OF on your own for practice. We are given f of x as cube root of x minus 1, g of x as x cubed plus 1. And we want to verify the two functions are inverse functions, and we know that their composite function must be x. If that's the case, we look at the composite function FOG. If it becomes x, that's a proof. So let's show that FOG equals x. And again, if it's helpful to put brackets or parentheses here, we will do that. So what is FOG? Here's the f function. FOG, replace the x with the g function. FOG, replace the x with the g function. As you can see, positive 1 and negative 1 cancel each other. We get cube root of x cubed, which is x, and that's a proof. Now this is simple enough. We can look at the GOF. Again, you don't have to, one is enough. You can look at GOF, which means replace the x here with the f function. So GOF would be parentheses cube root of x minus 1 to the third plus 1. So the cube root and the exponent 3 cancel each other. X minus 1 comes out. Obviously, minus 1 and plus 1 cancel each other. The answer is x. And again, that's a proof. You don't have to use both of them. One is good enough for the proof.
To confirm, the O between F and G is meant to symbolize of.
Of, exactly.
Okay.
Of the composite function. Absolutely.
But they just shortened it to only O.
Precisely.
Okay.
Excellent. FOG, f of g of x. All right, we want to come up with a rough sketch of the inverse function given the graph, in which case you always know a couple of things. First, the line y equals x. Two functions are inverse of each other if they are symmetric with respect to the line y equals x. That's one thing. The other thing is that as long as we find a few pairs on one, we can find a few pairs on the other. So you should always look for easy pairs. For example, this seems to be located at -2, -4. Which means f of -2 is -4. Which means -2, comma -4 is one pair on the graph of the function f, then -4, comma -2 must be a pair on the graph of its inverse. Therefore, f inverse of -4 must be -2. I'm going to go over that one more time. I want to make sure everybody understands what that means. So as you look at this pair, this belongs to the function f of x. Therefore, -4 -2 must belong to its inverse. And you just write it up here. So this means -2, comma -4 it's to f of x, and this is red. An element of, looks like an epsilon, that's the meaning of it. So let's do that up there. And if that is the case, then -4 -2 belongs to the inverse function. That's the meaning of it. Let's look at another easy point. So that's the point on the inverse. Another easy point would be this point. F of 0 equals 4. Let's use a different color and write it as 0, 4, which means the pair 0, 4 is an element of the function f, or simply f of x. Therefore, four, 0 must belong to the inverse function f inverse of x, which means f inverse of 4 must be 0. And you can pick more points if need be. So any pair you pick on the f, you just interchange x and y. That's a pair on the graph of its inverse. So they look like this. Again, obviously, two pairs may not be enough. You can pick up easy points. For example, this one may be easy to read. There seems to be 1 and 3 here. Then the other one must be 3 and 1. If that one, again, assuming I read it as 1, 3. If this is 1, 3, which belongs to f, then 3, 1 must belong to its inverse. Okay. So those are easy points to find. Those are the pairs that we had. These are the other two pairs that we had. Okay. My apologies, class. This is -1. This is negative. One more time. Let me just make sure. So this one is located at negative 1, 3. So 3 comma negative 1 must belong to F inverse. We make it this point. Okay. If I go to this one, again, 2 more pairs, and you can keep on adding as many as you need to come up with the proper graph. All right. We want to sketch the graph of f of x equals minus x plus 1 when x is between negative 1 and 1 to at precisely x equals 1 and x squared. So it's important to know what we call this. It's a piecewise defined function. It's a piecewise defined function. So first, let's evaluate a few points just for the sake of argument. Then I'll show you how to graph them completely separately, then putting them together. So for example, if x is negative 1, that means we are in this portion of the graph, because when x is between negative 1 and 1, we have to use this function. So if I plug in here, minus negative 1 makes it 1 and 1, 2. Okay. If I plug in 0, I have to plug it in here and get 1, because again, 0 is between negative 1 and 1. So 0 goes in here. 1 at x equals 1, it's been given to be 2. So at x equals 1 is precisely 2. So this is 2. At x equals 2, when x is larger than 1, then I got to use this portion. So 2 makes it 2 squared, 4. 3 makes it 3 squared, 9. And so we have this corresponding y coordinates, and these are the pairs. And you can graph just using those. What I want to show you is that if I'm graphing this, I'm going to first approach it this way. Simply put, I'm going to look at this part, and let me use a different color. This is y equals minus x plus 1. I would graph it without paying any attention to the restriction yet. And all I need is a couple of pairs, although the endpoints like negative 1 and 1 would be a good idea. So for example, at negative 1, let's assume this is, and this is not to scale. So at negative 1, let's assume it's here. 2. At 1 is 0. Just plug in. If you plug in 1 into this, you get 0. And here's the graph. If I didn't have anything else, and just y equals minus x plus 1, if I didn't have anything else, of course, there's a restriction. I'm going to go to the restriction later on. This one, y equals x squared, is a parabola that opens up. So we have 0, 0. We have 1, 1. We have negative 1, 1. And it will, let me use a different color. And it will look something like this. This is y equals x squared. Assuming we are not paying any attention to the restriction. And of course, this means this pair 1 and 2. And even for that, let me use a different color. Okay, this would be if we didn't want to look at any restrictions, but there is a restriction. So starting with the restriction for the first one says, this works only between -1 and 1. So from -1, it works from here. Okay, so -1 to 1 to here. And I'm going to erase this and show you what happens. I'm going to erase this. So what happens is that I have this part. Stick with the green one. And this is a hole. Because of the fact that we don't have the equality. We have the pair 1, 2, and lastly, x squared is when x is larger than 1 for this part. So for the x squared, let me erase it. With the red one. It starts from 1, so that means from here goes up. That's the meaning of it. So let me show you with better graphs. This is the graph. For the line, for this part, you have this. And that's it. This is for the line. For the parabola, starts at 1. There's a hole here. There is this part. And we have this pair 1, 2. And so the graph looks like this. So you should be able to drop the portion which shouldn't be there in the first place. So this is a piecewise defined function. Now, what is the domain? Domain goes from -1 to infinity. What is the range? The range goes from 0 to infinity. Now, is 0 included? You see, we have a hole here. So 0 is not included. So we have a parenthesis. All right. We want to find the average rate of change for this function f of x equals x squared minus 3x as we go from 2 to 4. And as we remember, average rate simply refers to the slope, change in y over change in x. So when we are interested in average rate from 2 to 4, that means we want f of b minus f of a over b minus a, or f of x sub 2 minus f of x sub 1 divided by x sub 2 minus x sub 1, however you want to put that. So this is f of 4 minus f of 2 over 4 minus 2. That's what we want to evaluate, which means you plug in 4, and then you plug in 2, and you look at their difference. So when you plug in 4, you get 4 squared, or 16, minus 3 times 4, or 12. When you plug in 2, you get 2 squared, or 4, minus 3 times 2 is 6, and the denominator is 2. This is 4 minus, this is negative 2. So the numerator is positive 6, because it's 4 plus 2. Positive 6 divided by 2 makes it 3. For the next part, we want to evaluate this from x equals 4 to 4 plus h. So we basically use this. That's the idea. We are supposed to use this. So f of a plus h minus f of a over h. In this case, f of 4 plus h minus f of 4 over h. So what do? We plug in and evaluate. So plug in 4 plus h, you get 4 plus h squared minus 3 times 4 plus h. For this one, you can evaluate it again, or just use the fact that we came up with 4. Either way is fine. If you plug in 4, you get 4 squared minus 3 times 4, which is 12. And so let's square this one. You square this one, you get 16. 2 times 4 times h, you get 8h plus h squared. I hope everybody remembers that. A plus b squared is a squared plus 2ab plus b squared. Then you multiply negative 3 by 4 plus h, which becomes minus 12 minus 3h. Then you expand this one. You can write this one as 16, write this one as 12. So this is 4 plus h squared. Now, the reason I expanded it in this format, it's easy to see what cancels out. So 16 minus 16, 12 minus 12. Now, what are we left with? H2 and now 8h, negative 3h, they add up to 5h, which means I can factor out the h from the top. I can cancel out the h. I'm left with h plus 5 or 5 plus h, it doesn't matter. H plus 5 or 5 plus h. We're going to get linear functions. We're going to continue with the module 2 practice test. We want to find the value of x if a linear function goes through the following points and has the following slope. The points are x comma 2 minus 4 comma 6, and the slope is 3. So reminding everyone of a few things. When we discuss lines, here's the standard form, ax plus by equals c. Here's the slope intercept form, y equals mx plus b. is the point slope y minus y1 is m times x minus x of 1. Vertical line has the equation x equals a with the slope being undefined and the intercept located at a0. Horizontal lines have an equation of y equals b, m equals 0, and y-intercept at 0, b. Two lines are considered parallel if they have equal slopes and different y-intercepts. Two lines are considered perpendicular if their slopes are negative reciprocal of each other. For example, m1 is negative 1 over m2, or m2 is negative 1 over m1, or their product is negative 1. That all means the same thing. So what is the slope? Rise over run, or y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And we're going to calculate the slope given these two pairs. So now, let's do that. All right, so we want to calculate the slope, y sub 2 minus y sub 1, 6 minus 2 over x sub 2 minus x sub 1, minus 4 minus x, and that is equal to 3. We can do the cross product. Three times minus 4 minus x equals 1 times 6 minus 2, which is 4. 1 times 6 minus 2, which is 4. We distribute number 3, we get minus 12 minus 3x. We move the negative 12, add it to 4 to get 16. Divide both sides by negative 3, and we have the answer. So a quick recap. All you have to do, use these 2 points and rise over run to find the slope, and it must be equal to 3. You find the missing x variable. A town has an initial population of 75,000. It grows at a constant rate of 2,500 per year. Constant rate. Find the linear function that models the town's population P as a function of the year T, where T is the number of years since the model began. Since that time. So obviously we are going to use y equals mx plus b, and we are going to change the y to p. That's how they want it. And we're going to change the x to t. Now, clearly you can see that the initial population is a fixed value. That's the meaning of your y-intercept, in this case p-intercept, so that's 75,000. And m is the rate of change, is 2,500. So it's easy to see that this becomes 2,500 t plus 75,000. But let me explain a little bit more by going over this. P of t is the population as a function of time. M is the constant rate of growth of the function. In this case, it's 2,500 per year. T is the time elapsed in units of years, because they said so. B is the initial population, which in this case, it's 75,000. So the linear function becomes 2500 T plus 75,000. I would just wanted to make sure that you have all the details. Monthly cost of a cellular plan depends on the number of minutes used and a flat fee. 410 minutes cost us $71.50. 720 minutes cost us $118. And we know it depends on the number of minutes used and a flat fee. So right away, it becomes a linear function. So express the cost as a linear function of the monthly minutes used X. So we have to write the X comma Y, in this case, X comma C, where X represents the minutes and C represents the cost. So we have two pairs. So X comma Y becomes X comma C. X is the number of minutes, the independent variable. C is the cost. So 410 minutes cost us $71.50. 720 minutes cost us $118. So we got to find the slope M, which is rise over run. Y sub 2 minus Y sub 1 over X sub 2 minus X sub 1 becomes C sub 2 minus C sub 1 over X sub 2 minus X sub 1. So instead, remember, we had normally we had X and Y is being replaced by C or cost. So $118 minus $71.50, that's the numerator, over 720 minus 410, that's the denominator. We get 46.5 at top, 310 at the bottom, or you can write 465 divided by 3100 and it becomes 3 over 20 or 0.15. That's the slope. We had Y minus Y1 equals M times X minus X sub 1 as a point slope. Now we have C minus C sub 1 equals M times X minus X sub 1. And we use one of those pairs. For example, C minus 118 is 3 over 20, X minus 720. So Y minus Y1 equals M times X minus X sub 1. That's what we are using. And we are changing the Y to C. So we distribute the 3 over 20. We move this, that means we make it plus. So add 118. And C becomes 3 over 20x plus 10. That is the cost in general. What is the cost using 687 minutes? I'm going to replace the X with 687 and calculate that. You can use a calculator if you want. Divide this one by 20 times 3 plus 10, and we get $113.05. So if we use 687 minutes, this is how much they're going to charge us. Now, what is the meaning of the slope and a C-intercept? What is the meaning of do the interpretation? The C-intercept, if you go back to this, equation, C equals 3 over 20 plus 10. This is the flat fee. The C-intercept represents this fixed monthly fee of $10. That is fixed, meaning no matter how many minutes they're going to charge us this much. Now, as we use and we add to the minutes, then we plug it in here and the cost becomes more and more as it happened here. So the slope, which is 3/20, okay, or 0.15, the slope represents the change in cost per minute of call for the amount of 0.15 per minute. So the slope represents the change in cost per minute of call for the amount of $0.15 or 15 cents per minute. 3/20 is 0.15. Let me just make sure I didn't see what happened here just in case. So this number 3/20, which is the slope, equals 0.15. The height in inches of a sunflower X weeks after being planted can be approximated by the function f of x equals 6x minus 1/4 x squared. How tall is the sunflower 8 weeks after planting? So simply put, plug in 8 into this formula. We want f of x, so 6 times 8 minus 1/4 8 squared. This is 48. This is 64. 1/4 of it is 16, and it becomes 32. This is where we get the units, 32 inches. Any word problem, you want to answer them with proper units. Find the average rate of growth from the end of week 6 to the end of week 12. Include proper units. It simply means delta y over delta x, rise over run, f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1, or f of 12 minus f of 6 over 12 minus 6. That's the meaning of it. So we plug in 12 and we plug in 6. So 6 times 12 minus 1/4 12 squared, minus we plug in 6, 6 times 6 minus 1/4 6 squared. And we need to evaluate this. It's elementary algebra. So this is 144 divided by 4 gives you 36. So we have 72 here minus 36. Over here we have 36, and this is 36. But 1/4 of it is minus 9. I hope you see that this cancels out this one and this one. So you have 9/6, or 3/2 inches per week. Why is this the unit? The top is the difference in f of x, which is in inches. The bottom x is in weeks. So 3/2 and the units of the top over the units of the bottom, just the way it's given. So The average rate of growth from week 6 to week 12 is that it's growing at 3/2 of an inch per week. The sunflower. You may remember this question. A fitness club charges $20 as a monthly access fee and $2 per day. That is a fixed cost, if you will, the y-intercept, and this is the slope. Express the monthly cost in terms of daily average. We normally would write y equals mx plus b. Let me just write that. Normally we would say y equals mx plus b. This is b, this is m. Instead of y, we are going to use c. Let x be the number of days, and we're going to use c of x equals 2x plus 20. Now, what will be the monthly cost if we use it for 15 days? Replace it. 2 times 15 is 30. Add it to 20 and you get $50. So the cost would be $50 for that month.
I have a question.
Go ahead.
Why did we make C of X C of 10?
15. Oh, this is a typo. I'm glad you mentioned that. Thank you so much. It
No
is 15. Absolutely. And notice we did use the 15. So this is a typo. Thank you so much. It's definitely C of 15. And the answer is $50. So if we use it 15 days, then it will cost us total of $50. I want to look at this question also. We want to find the absolute max and the absolute mean if they exist. So notice this is the location of an absolute max because there is no other point having a larger y coordinate. So absolute max equals the y coordinate of this point, which is 6 at 3, 6. Absolute mean, this point, there is no other point having a smaller y coordinate. So absolute minimum equals the y coordinate of that, which is 1 at 0, 1. When you answer these questions, just you want to answer the way they want you to answer. So this is one way, precisely the extremo. We are interested in their y coordinates, but they may want it at a specific point. You want to answer it accordingly. In this case, no other point has a larger y coordinate, so the absolute max is 3 at 5, 3. If we had a dot here, a solid dot, that would be the location of an absolute mean. Because we don't have it and it's discontinuous, at that point we say no absolute minimum because it's a hole here. There's a hole that's not part of the graph. In this case, no other point has a larger y coordinate. So this is the location of an absolute max. So absolute max is equal to number 4 at this pair. Absolute mean, this is the bottom, and the y coordinate is 1, but anywhere from 1 to 2, in the interval of 1 to 2, all of them have the same y coordinate 1. So in this case, it doesn't happen at one point, it happens in infinitely many points. So the way we write it is absolute minimum equals 1, the y coordinate, anywhere from this x coordinate to this x coordinate from 1 to 2. This is the absolute mean.